Hey friends, welcome back. Let's see some more questions on the ROC and linearity property. Okay. Let's see. Example. E power minus 2t u of t plus e power 4t u of minus t. For this, we have to say what is the Laplace transform. First of all, what is the ROC for this signal? Sigma greater than minus 2 because right sided pole is minus 2. For this one, sigma less than 4. If I see minus 2 plus 4. So greater than minus 2. This is what greater than minus 2 means. Next, less than 4. This is what less than 4. So this is the common ROC, that is sigma lies between minus 2 and 4. Minus 2 and 4. So if I write this one, so whenever common ROC exists, then we can take Laplace transform. That means we can apply the linearity property. 1 by s plus 2 minus 1 by s minus 4. Why I have taken minus here? Because I told you, whenever you see e power 4t, then you have to write 1 by s minus 4. And you have to change the sign because it is a left-sided signal. I told you, whenever the signal is left-sided, then we have to change the sign. So this is what we are going to get. S minus 4 minus s minus 2 by s plus 2 into s minus 4. So what we are going to get? Minus 6 by s plus 2 into s minus 4. Here ROC is minus 2 less than sigma less than 4. That's for the meaning of it. Next. Next example. E power minus 2t u of minus t minus e power minus 4t u of minus t. Again, let's say for this signal sigma less than minus 2, for this signal sigma less than minus 4. If I show them minus 2 minus 4, sigma less than minus 2, so this is what the sigma less than minus 2. Sigma less than minus 4. So here the common ROC is this one, sigma less than minus 4. So if I take Laplace transform, because both are left-sided signals, so we have to change the sign for both the signals. Because it is plus, we have to write minus 1 by s plus 2. Plus 1 by s plus 4. 1 by s plus 4. Because it is a left-sided signal, I have changed the sign also. So minus s minus 4 plus s plus 2, s plus 2 into s plus 4. S get cancelled, minus 2 by s plus 2 into s plus 4. So that's what we are going to get. Clear? Take it. Next example. e power minus t u of minus t plus e power 5t u of t. Again we have to check what is the common ROC. Before applying any linearity property, we always have to check whether it is having common ROC or not. Because it is a left side signal, sigma less than minus 1. Because it is a right side signal, sigma greater than 5. So if you observe carefully, 5 is here. For this one, sigma greater than 5. So this is the ROC. Minus 1 here. For this, ROC is here. Do we have the common ROC? No common ROC. That implies no Laplace transform. No Laplace transform. Clear? Take it. Okay. Next. Cos omega naught t u of t. For this one, I want to find out what is the Laplace transform and ROC. How we can do this? Let's say this can be written as 1 by 2 e power j omega naught t u of t plus 1 by 2 e power minus j omega naught t u of t. We can write e power j omega naught t plus e power minus j omega naught t by 2. So if I expand this, this is the one. Okay. Now let's see. If I ask u of t having Laplace transform 1 by s with ROC sigma greater than 0. Okay, everybody knows it. If I multiply this with e power, let's say at u of t, then we have to replace it with s minus a, sigma greater than 0 plus real part of a, real part of a. So that's what it is. Suppose e power j omega naught t u of t is there. This one. What is the Laplace transform? S is replaced with s minus j omega naught. Clear. And sigma greater than 0 plus real part of j omega naught. What is the real part of j omega naught? That is 0. So again sigma greater than 0 only. Sigma greater than 0 only. So for this one, still sigma greater than 0. For this one also sigma greater than 0 only. So what is the common ROC? Sigma greater than 0, sigma greater than 0. So the common ROC is sigma greater than 0. Now we are having common ROC. Then we can apply Laplace transform. 1 by 2 1 by s minus j omega plus 1 by s plus j omega naught. That is 1 by 2 s plus j omega naught, s minus j omega naught get cancelled, j omega naught, 2s by s square plus omega naught square. 2 get cancelled. Finally, this is nothing but s by s square plus omega naught square with sigma greater than 0 as ROC. So you have to remember it is standard form, cos omega naught t u of t having Laplace transform s by s square plus omega naught square sigma greater than 0. Take it. Sin omega naught t u of t. This can be written as 1 by 2 e power j omega naught t u of t minus e power minus j omega naught t u of t by 2j. So it has to be 2j. Okay. So if I say what is the sigma greater than 0 is the ROC, sigma greater than 0 is the ROC. So I can apply the Laplace transform. Then what is the Laplace transform here? X of s 1 by 2j 1 by 1 s minus j omega naught minus 1 by s plus j omega naught, that is equal to 1 by 2j. So this is going to be 2j omega naught by s square plus omega naught square. 2j get cancelled, finally omega naught by s square plus omega naught square with ROC sigma greater than 0. So for sin omega naught t u of t, we can remember omega naught by s square plus omega naught square with sigma greater than 0. So this is what the e power minus at cos omega naught t u of t. For this one, what is the Laplace transform? What is the ROC? So here we know up to this point cos omega naught t u of t. Just now we have calculated cos omega naught t u of t. What is the Laplace transform? S by s square plus omega naught square with sigma greater than 0. With sigma greater than 0. If it is multiplied with e power minus at, so can I go with the exponential multiplication in time domain property? So if I multiply with exponential, then in the Laplace domain we have to replace s with s minus a, s plus a. So if I replace s with the s plus a, then we are going to get s plus a by s plus a whole square plus omega naught square. Then sigma greater than 0 plus real part of minus a. So we can go for sigma greater than minus a. That's what it is. So in the similar manner, e power minus at sin omega naught t u of t having Laplace transform omega naught by s plus a whole square plus omega naught square. Here also sigma greater than minus a. Take it. If I ask, what is the Laplace transform of 1? Simple constant 1. So many people will say 1 by s. That is a wrong answer. That is also correct answer. What do you mean by this? That means for 1 Laplace transform 1 by s. Yes, if it is a unilateral Laplace transform. But we are discussing the bilateral Laplace transform. Let's see then what is the Laplace transform for it. We know one can be written as u of t plus u of minus t. I can write like this. Once we could write like this, for u of t, we are having sigma greater than 0 is the ROC. For u of minus t, sigma less than 0. Sigma greater than 0, sigma less than 0. Do we have the common ROC? No. No common ROC. So that means Laplace transform of 1 does not exist. Does not exist. So here bilateral Laplace transform does not exist. In the similar manner, suppose if I say x of t is equal to signum t. Signum. Signum t also can be written as u of t minus u of minus t. So here also the same problem. We don't have any common ROC. So sigma greater than 0, sigma less than 0. No common ROC. So here Laplace transform does not exist. Does not exist. In the similar way, suppose if I say x of t is equal to cos omega naught t. So in the previous case we are having cos omega naught t u of t, but if I simply say cos omega naught t, so we can assume cos omega naught t multiplied with 1. That 1 can be written as u of t plus u of minus t. Then this is nothing but cos omega naught t multiplied with u of t plus u of minus t. So this is nothing but cos omega naught t u of t plus cos omega naught t u of minus t. So for this signal we know the ROC is sigma greater than 0. For this signal ROC is sigma less than 0. Here also we don't have any common ROC. Whenever there is no common ROC, I can simply say Laplace transform does not exist. No common ROC. That implies Laplace transform does not exist. So be careful. Cos omega naught t u of t having the Laplace transform, whereas cos omega naught t does not have the Laplace transform. Clear? Take it. Next. Suppose if the question is like this, x of t is equal to e power minus a mod t, where a greater than 0. For this function, I have to calculate the Laplace transform and ROC. This function can be written as e power minus at u of t plus e power at u of minus t. So here this is having sigma greater than minus a is the ROC. This is having sigma less than a is the ROC. So because a is positive, sigma greater than minus a, that means this is the ROC. Sigma less than a, so then this is the ROC. Common ROC is this one. So what is the common ROC? Minus a less than sigma less than a. This is the common ROC. So if it is a common ROC, I can go for Laplace transform. 1 by s plus a minus 1 by s minus a. Why I have used minus here? Because it is a left sided signal. So s square minus a square by s minus a minus s minus a. So minus s minus s can cancel, minus 2a by s square minus a square with minus a less than sigma less than a. Take down this question. For the following pole zero pattern, pole zero plot, obtain the number of possible ROCs. Possible ROCs and mention them. Mention them. So this is the pole zero pattern they have given. For this pole zero pattern, how many ROCs are possible? Understand this. So the first condition what we have to remember about the ROC is, ROC should never contain any pole. If it is containing any pole, that is not the ROC. Okay. So how many ROCs are possible for this? It may contain 0. So if it contains 0, it won't make any difference. Now we are going to have 4 ROCs. What are they? Let's see. Greater than 2. So ROCs means it is a common ROCs we are talking about. Greater than 2. Less than -3, that is a 1 ROC. In between -3 and -1. In between -1 and 2. Next, can I take ROC in between -3 and 2? So we cannot take that because it is having the pole inside. So I am having 4 ROCs here. What are they? First one, sigma greater than 2. Second one, sigma less than -3. Third one, sigma lies between -1 and 2. Next, fourth one, sigma lies between -3 and -1. So these are the 4 ROCs are possible. Actually, there is a direct formula to say how many ROCs are possible. So number of ROCs is equal to number of real poles plus number of complex poles divided by 2 plus 1 plus 1. So this is the number of ROCs. Now if you observe carefully, how many number of real poles are there? 3. How many number of complex poles we are having? No, we don't have any complex poles. Plus 1. So it is nothing but 4. So this is the formula you have to remember. Next, one more thing I want to ask. Suppose if a system or if let's say x of s having this kind of pole zero pattern. For this kind of pole zero pattern, if it is x of s, then how many x of t are possible? That means how many inverse Laplace transforms are possible? That is entirely number of ROCs. Why? Depending on this ROC, we can write a signal. Depending on ROC, we can write a signal. So like that, how many signals we can write? X of t signals we can write 4 ways. So I can simply say the number of inverse Laplace transforms are is equal to number of ROCs is equal to. So I can say the observation point here, note the number of inverse Laplace transforms is equal to number of ROCs. Number of ROCs. So that's what you have to remember. Clear? Take it. Question. The transfer function of a continuous time control system. The transfer function of a continuous time control system is given by h of s is equal to minus 7 minus 5s by s plus 2 s plus 1 s minus 1. Obtain possible impulse responses comment regarding the existence of Fourier transform to impulse response. Impulse response. Third question. Draw ROC in each case and comment regarding causality and stability of the system. Take it. Take this question. This question is very important. By understanding this question, you can understand so many new things here. So if h of s is given, they want to calculate impulse response. That means impulse response h of t and h of s is nothing but the transfer function. So if I find out the inverse Laplace transform, they are nothing but the impulse responses. Here if you observe carefully, we are having 3 poles. So 3 real poles. Then how many possible ROCs are there? There are nothing but 4 ROCs are there. So if 4 ROCs are there, correspondingly we can write h of t in 4 ways. That means we are going to get 4 impulse responses. Once we know the impulse responses, we have to check whether the Fourier transform exists or not. So then we have to check whether the system is causal or stable or not. So we have to see these kind of things. Okay. So let's see one by one. First we have to see what is h of s. If I do the partial fractions here, then we are going to get the partial fractions 1 by s plus 2 plus 1 by s plus 1 minus 2 by s minus 1. So if I do the partial fractions, these are we are going to get. Next, what are the poles here? 1 minus 1 minus 2. So these are the poles we are having. 1 minus 1 minus 2. These are the poles. If these are the poles, then number of ROCs. What are the ROCs are there? 4 ROCs. 4. What are they? First one, sigma greater than 1. Second one, sigma less than -2. Third one, sigma lies between -1 and +1. Fourth one, sigma lies between -2 and -1. These are the 4 ROCs are there. Correspondingly, we have to write. So for each ROC, what is the inverse Laplace transform? So whether it is having Fourier transform, whether it is stable or causal, these kind of things we have to check. First take up to this. So finally we got h of s is equal to 1 by s plus 2, 1 by s plus 1 minus 2 by s minus 1. Let's see. First, sigma greater than 1. Sigma greater than 1. So this is what the ROC is. If this is the ROC, we have to see. For each pole, it is a right-sided ROC because for 1 it is right side, for -1 it is right side, for -2 is also it is right side. So everything is right-sided signal here. So while we are writing h of t, what is h of t? E power -2t u of t plus e power minus t u of t minus 2 e power t u of t. So this is what h of t. This is what h of t. I hope it is over. Now, if it is h of t, we have to see whether it is going to be Fourier transform is possible or not, or next thing is whether it is a stable system, whether it is a causal system or not. Okay. So let's see. You might know. For a signal, whether the Fourier transform exists or not, what we have to check, whether it is bounded or unbounded. That's what we have to check. So let's see. Bounded, bounded, unbounded. So because the signal is unbounded, we can simply say Fourier transform does not exist. So first writing this one, h of t is unbounded. That implies Fourier transform does not exist. Does not exist. Second one, h of t, whether it is a causal system or non-causal system. So we have discussed the properties of LTI system. There we have seen h of t is equal to 0 for t less than 0. That means if h of t does not exist for t less than 0, negative values of time, then we can call that system is a causal system. So if you observe carefully, u of t, u of t, u of t, everything is u of t. That means everything is existing from 0 to infinity only. So I can say the system h of t, impulse response h of t, is equal to 0 for t less than 0. For t less than 0. That implies system is causal system. Causal system. Next, third one. To say h of t represents a stable system or not, we have to see whether it is absolutely integrable or not. So if the system is, if h of t is absolutely integrable, then we can get it is a stable system, otherwise it is unstable system. So if you observe here, area under this one finite, area under this one finite, but area under this one is infinite because it is a growing exponential. So I can say integral minus infinity to infinity mod h of t dt is equal to infinity. That implies unstable. That implies unstable system. I hope understood. This is the one. Next, So I am not going to write every time this kind of things, just you can understand one by one. Next, second case, sigma less than -2. Sigma less than -2 means this is what sigma less than -2. So for every signal we have to write left side signal, because for -2 left side ROC, -1 left side ROC, +1 is also left side ROC. Then what is h of t? H of t is equal to everything we have to write in the left side. So minus minus plus, sign has to be changed. Minus e power -2t u of minus t. Next, minus e power -t u of minus t plus 2 e power t u of minus t. So let's see first whether it is a Fourier transform exists or not. Fourier transform exists or not. Let's see. H of t is bounded or not. So this one, bounded or unbounded? Unbounded, unbounded, bounded, because left sided exponential has to be growing exponential to become bounded. So this is a bounded, these two are unbounded. So h of t is unbounded. So Fourier transform does not exist. I am not writing every time. Fourier transform does not exist. Does not exist. Second one, causal or non-causal? Non-causal, because everything is existing for negative values of time. So it is non-causal. Non-causal. Next, third one, stable or unstable? Because these two are unbounded, if you try to find out modulus area, then it is going to be infinity. So it is unstable. Unstable. Next, third case, sigma lies between -1 and +1. This is what the ROC they have given. For this ROC, let's see. For 1, it is left sided. For -1, right sided. For -2 also right sided. So for this one we have to write right sided signal. For this one we have to write left sided signal. So if I write that, then let's see what is h of t looks like. Right side, e power -2t u of t. Next, again right side, e power -t u of t. Left side, plus 2 e power t u of minus t. U of minus t. Observe it again. This one bounded, bounded. It is also bounded. So Fourier transform exists or not? Yes, Fourier transform exists. H of t is bounded. That implies Fourier transform exists. Fourier transform exists. Next, h of t, is it equal to 0? No, h of t is not equal to 0 for t less than 0. That implies non-causal. Non-causal. Third one, h of t, is it absolutely integrable? No. Why? Sorry, it is absolutely integrable. Why? Because it is bounded, it is also bounded, it is also bounded. If I try to find out area under this curve, so still it is going to be bounded function. So integral -infinity to infinity mod h of t dt less than 0. So sorry, less than infinity. Less than infinity. That implies it is stable system. It is stable system. Next, fourth case. minus 2 less than sigma less than minus 1. Minus 2 minus 1 1. So ROC like this. This is ROC. So if you observe ROC, for 1 it is a left sided, for minus 1 it is left sided, for minus 2 it is right sided. So how we can write h of t? For first term is the right sided, e power minus 2t u of t. Next minus e power minus t u of minus t plus 2 e power t u of minus t. Observe it. Fourier transform exists or not? Let's check it out. Bounded, unbounded, bounded. So again unbounded. So it is going to be Fourier transform does not exist. Does not exist. Second one. H of t, is it equal to 0? No, h of t is not equal to 0 for t less than 0 because we are having u of minus t, u of minus theta. So h of t exists for negative values of time. So it is non-causal. Non-causal. Next, third one. Stable or unstable? It is unstable again because this is bounded, this is unbounded. Because of this unbounded, if we try to find out area under the curve, that will become infinity. So it is unstable. It is unstable. Clear? Take it. Condition on ROC. So to say it is a causal system, h of t should not exist for negative values of time. So if it is existing only for positive values of time, every term must be right-sided signal. If it is a right-sided signal, then only we don't get any left-sided one. That means we don't get signal which is for negative values of time. So to get everything right-sided, what is the condition? To get everything right-sided, what is the condition? So every signal has to be written in terms of right-sided. That means for every pole, the ROC must be right-sided. Is that clear what I am trying to say? So for every pole, if the ROC is right-sided, then we can get the signal which is causal. Then we can get the signal is causal. Otherwise we will never get causal. I hope you understood. So can I simply say the ROC is right side to the rightmost pole? If ROC is existing for right side to the rightmost pole, then we can call that system or signal as causal system. Next, one more thing. To say a system stable and Fourier transform exist, both are having the same. So h of t must be bounded. So here Fourier transform exists, stable, and nowhere Fourier transform exists. Then what is the condition on ROC? That is nothing but ROC should contain j omega axis. This is the only ROC where j omega axis included in the ROC. Otherwise, nowhere we are having that one. So that's why we are having the system which is having Fourier transform and stable. This is the one thing. I hope you understood what I am trying to say. So to say a system causal, what is the condition? ROC must be right side to the rightmost pole. To say a system stable or Fourier transform exists, then ROC should include j omega axis. ROC should include j omega axis. Suppose if I ask, given system is stable, but from the control system, if a pole is existing on the right half of a plane, then the system is unstable, right? But why we have written it as a stable system? Because the system what we are considering is a non-causal system. But in control system, every system is a causal system. So think about this point. In the next class we will see. To become a system, both causal as well as stable, what is the condition? What is the condition? I hope you understood. So we have seen for causality, we have seen for stability. But if I combine both the properties, then what is the condition we can create? So we will see in the next session. Okay, thank you.